Simplifying expressions. Our objective is to use the commutative, associative, and distributive properties to simplify expressions, as well as combining like terms. Why learn this? Triathletes can use the commutative, associative, and distributive properties to calculate overall times mentally. The commutative property. You can add numbers in any order and multiply orders in any number. So it doesn't matter if you add 2 plus 7 or 7 plus 2, in the end you're getting 9. Same way if you're multiplying 3 times 9 or 9 times 3, either way you look at it is going to give you 27. The associative property. When you are only adding or multiplying, you can group any of the numbers together. So not when you're mixing multiplication and addition together, when it's all addition or all multiplication. So you have 6 plus 8 plus 2. You can do the 6 plus 8 first, or you can do the 8 plus 2 first. In the end, either way you go about it, you're still going to end up with 16. For multiplication, you can go with 7 times 4 as a group, or 4 times 5 as a group. Either way you go about it, you're still going to end up with 140. So commutative property, you can change your order. Associative property, you're changing your grouping. Let's simplify each expression. So we're going to use the commutative and associative properties. Alright, so we want to be able to do these mentally. So sometimes grouping things together in different combinations makes a problem easier to solve. So for example, for this one, we're going to want to put our 9, switch our 9 and our 4. This way we can multiply 4 and 25 first, because 4 times 25 is 100. And then do 9 times 100 to get 900. It's a little bit easier than multiplying 9 times 4, getting 36, and then trying to do 36 times 25 in your head. It's much faster to go, oh, 4 times 25 is 100, multiply that by 9 gives us 900. So try B. Switch the orders around, switch the grouping in terms of which ones you add together to try to do this mentally. Now that you've had a moment to try it on your own, let's try it together. So we're going to switch our 75 and our 48, because it doesn't matter which ones we're switching around, they're all addition. That way we can group our 25 and our 75 together. Because 25 and 75 give us 100, which ends with 148. Much faster than if you were to say, try to add 25 and 48, and that would be 73, and then you're going, okay, well 73 and 75, that's going to give me like 140, and then we do our 8 and our 3, okay, that's going to give, 5 and 3, and that's going to give us our 8. Way more math than if you were just go, okay, 75 and 25 make 100, add on the 48. Let's look at the distributive property. So you can multiply a number by a sum or multiply each number by the sum and then add. So either way the results will be the same. So we have 3 times 4 and 3 times 8. We're distributing this 3 to each piece because it's the same as saying, well, 4 plus 8 is 12, so 3 times 12. It's the same thing as saying 3 times 4 plus 3 times 8. You're distributing. So hence distributive property. So write each product using the distributive property. Sometimes splitting things up and then adding makes it a little bit easier to solve the problem. So let's look at this first one together. So we can look at 15, and then we can split 103 into 100 plus 3. That way we can do 15 times 100 and 15 times 3. 15 times 100 is 1500, and 15 times 3 is 45. Now we can just go, okay, 1500 plus 45 gives us 1545. Much easier than trying to go 15 times 103. When you split things up, sometimes it makes it easier to do things mentally. Try it with B. Now that you've had a chance to try it with B, did you find it difficult to try to use addition with this one? Subtraction might have been the best way to go, because 19 is really close to 20. So we can go 6 times 20 minus 1, because 20 or plus negative 1 is 19. Now we can distribute, so we have 6 times 20 and 6 times negative 1. So 6 times 20 and then 6 times negative 1. 6 times 20 is 120 plus negative 6. So 114. Much easier to have it split up than to try to do 6 times 19 off the top of your head. Let's look at like terms and unlike terms. Alright, so your like terms, when you have like terms, your variables are the same. So like 4x and 3x, they are like terms. 2 is not a like term with 3x. It needs to have an x to be like terms. Likewise, if we had 1x squared and 3x, these are not like terms. X squared is not the same as x. So 4x and 3x are like terms. We would classify 2 as our constant. It's not changing, it's just a value of straight up 2. We can't call 3x constant because we don't know what x is. It could be something random. So constants are only for solid numbers. So hey, 2 or 20 or 53 or negative 1/5. Those are constants. They're not able to be changed. So your coefficients are the numbers that go right in front of your variables. So if you don't have, so say you had x to the third, and you don't have anything written in front, you can always assume a 1 is in front, because if you have x third, how many x cubes do you have? One of them. So 1x cubed is the same thing as saying x cubed. So your coefficient is just the number in front, nothing else. Coefficient, just the number in front. So once again, like terms are like 4x and 3x. Your constant is unchanging, and your coefficients are the numbers that go right in front of your variables. Let's try combining like terms. So once again, you can only combine like terms. If they're not like terms, you can't go putting them together. So we have 12x and 30x. Both of them have an x, and they're the same. So therefore we have 12x's plus 30x's give us 42x's. Try B and C on your own. Pause the video. Now that you've had a chance to try these on your own, let's try them together. Alright, so we have an x or y squared and a y squared. They are like terms, but how do we combine this one? We don't have anything in front of it. Well, we can always place a 1 in front, because if you have a y squared, how many of them do you have? You have one of them. Alright, so now we have 6.8y squared minus 1y squared. So 6.8 minus 1 gives you 5.8 y squared. Alright, let's look at C. We're trying to get tricky here. We've got 4n plus 11n squared. Well, we have n and n squared. We can't combine those. So how am I supposed to simplify this? Well, it's already simplified. You can't go any further. You cannot combine n squared with n. They are not like terms, so do not combine them. Alright, let's look at simplifying algebraic expressions. Alright, so we want to make sure that we can simplify here, and we're going to justify each step with an operation or property. Alright, so we have this 2 times the quantity x plus 6 plus 3x. And we're justifying this by, hey, they just kind of gave this to us, so it's given. That's what we're starting with. Alright, so now we want to simplify this. So what can we do first? We can't combine what's in parentheses because x and 6 are not like terms. But we have this 2 out here. So we can distribute this 2 to each piece. So 2, when you distribute, you multiply, not add, multiply. So we have 2 times x, which is 2x. And then we have 2 times 6, which is 12. Just bring down that plus 3x. It's sort of just chilling there. And why were we allowed to do this? Well, we just did the distributive property. So there's our justification. We use the distributive property. Alright, well, now that we've used our distributive property, we're going to need to move things around a little bit. So, because we can't add 2x and 12, because they're not like terms, but we can add our 2x and 3x. So we have 2x plus 3x plus 12, so we just use the commutative property, and now we got to keep going. So changing colors again here, we've got, let's go with green, and we're going to group some of these together. So we're going to group our 2x and our 3x together, which will give us 5x plus 12. So we just use the associative property. And then after we use that associative property, we went and combined like terms. Alright, well, can we go any further? Nope. 5x and 12 are not like terms, so that is your end result. You have just simplified an algebraic expression. And that also ends our lesson on simplifying expressions.